Hey guys, these are your notes on tossed up projectiles, just to sum up what we know about them. So the first thing I would like you to draw is this strobe photo, which I have here. I have 5 pictures of a ball that's thrown straight up into the air. As you can see, on the way up, first here's where the ball is thrown on the left side, and on the way up, the ball's pictures get closer together. So that shows that the ball is slowing down. You could say that's on the way up, it slows down, right? And then on the way down, after it gets to its maximum height, the ball's pictures get further apart. So on the way down, next to your strobe photo, I'd like you to write that it speeds up. Alright. And what else do we know about a projectile that's launched up into the air? We know about time. First thing we'd like to define is the hang time of the projectile. It's the total time in the air. That's what we mean by hang time, the total time that a projectile spends in the air. Alright, what do we know about hang time? We know that we could split up hang time into the time up and the time down, and that it splits up equally, like this. Boom, right there. Splits up equally into time up and time down. So the hang time is equal to either twice the time up or twice the time down. Alright? Hang time splits up equally into time up or time down. And if you double time up, you get your hang time. If you double the time down, you get your hang time. What else did we look into? Well, if the object slows down on its way up and speeds up on its way down, what do we know about its maximum height? What do we know about how fast it's moving right there? We know that at its maximum height, for a moment, not even a period of time, just a moment in time, it doesn't have a speed. So at its maximum height, the velocity of a projectile is 0. Okay. And the last thing we know about a projectile is about 2 other velocities that occur. We know that if you launch a projectile up in the air, on the way down, right before it gets back to the ground, right before it hits the ground, its speed that it hits the ground at is equal to the speed it was launched at. So we could say it's VI, the speed it was launched at, equals the speed it hits the ground at. But the only difference is that the VI is up, so it's a positive, and the VF is down, so it's a negative. Alright? So basically, if you take the negative of your VI, you get your VF. So if it's launched up at positive 5 meters per second, then it'll hit the ground at negative 5 meters per second. There's a symmetry to objects launched straight up in the air, that time up equals time down, and if you double any of them, you get hang time. And that the speed you launch something at is the speed it hits the ground at.